Okay, so building on this exercise, we're going to talk a little bit about random distributions, and we're going to set up a tiling for that. So you can see here I've got a grid, and you can make it whatever size you like. This fills my screen relatively well, so I'm going to go with that. I'm going to get into Rhino for a second here, and similar to what we saw before, I'm just going to draw a box, and then I'll draw another one. All right, just two rectangles. Okay. And then for this one, I'm going to draw an arc. So I'm just going to select that arc command there. I'm going to start at a corner, go to the midpoint, and the other midpoint that's adjacent there. Do another arc similar to that. And then I'll draw the opposite of this, starting with the other two corners. All right. I do that. And now with this setup, these are the only two really that I can have. This kind of exhausts all possibilities in terms of the way these tiles are related to one another. So that's really what we need. And so let's go ahead and start bringing this stuff in, kind of like what we saw in the last one. So I'll grab, first of all, these first two curves here for tile 1. I'll grab the next two for tile 2. And I'll grab the boundaries for the tiles. And the other ones as well. Alright. Looks good. Tile 1, tile 1, tile 2, tile 2. Great. Okay, well, we still need to set a group, so I'm just going to go ahead and group those that tile geometry, right? So just the two curves in there like that. And in this case, we're going to jump directly into remapping before we start organizing the pattern. Okay, so I'm just going to go back over to transform here. Under Affine, you'll find the rectangle mapping like we did before. The target are these boxes, our grid boxes here. You can zoom out a bit. The geometry we're dealing with is the tiling. And I'm not going to merge anything this time. Actually, we're going to end up using two of these. We're going to make two overlapping patterns, and then we're going to kind of break it down from there. And then these here are the boundaries for that one. Okay, so that's going to start showing up. I'm going to do another one, copy and paste that. Instead with this, and I'm going to use, making sure that we're using the proper. Okay, so it's going to look like circles. It's not, but it's going to look like it. And we can verify that here. Right? So we have kind of these opposite overlapping patterns emerging here. Now we're going to use a random, basically a random selection process to remove some of these and keep others in order to kind of reveal this really interesting sort of looping continuous lines that interlock with one another. Okay, so I'm going to go over to sets here, and I'm going to grab under sequence, the random component. This is going to kind of, it's a pseudo-random number generator. I am going to need a range for this. And we really just need a min-max to cover all possible tile options, which really are only two. So it's really just zeros and ones. Now, if we want a random distribution of zeros and ones, we can get a more even distribution if we kind of expand our domain for that. And there's a little trick for this. So what I'll do is I'll grab a construct domain component. And the way I've been doing this is to just sort of place in so let's just do a negative 0.49. Right, because we're going to do some rounding. This will make sense in a minute. So negative 0.49, and then I'm going to go with 1.49, positive, so 1.49. Put that into B. And then this is going to come into our input there. The number of things overall that we need is going to come from the number of cell outlines we have, right? Number of grid outlines. So we'll go to set length. There's the length here, and that's where we put that in there. We'll deal with the seed in just a moment. Now, there's going to be some decimal points here. In order to do some quick, simple rounding, we can just force those to be integers. Okay, so we can just grab over here under parameters and primitive this little 7, right, the integer component. And now that's going to give us a bunch of zeros and ones because those decimal values are going to be those random numbers that are between at its lowest value this and its highest value that, they're going to be between those. And those decimals are actually pretty, they're 5 or 6 values past the decimal point, but they'll still round to either the closest 1 or the closest 0. And again, if we expand a little bit of our domain for this, we'll get more ones and zeros in a more kind of like evenly distributed way, given the random algorithm that's basically being used here within this little black box. All right, so that gives us a bunch of ones and zeros, which is what we need in order to kind of break this pattern down. And now to do that, we're going to arrange the tiles using the pick and choose. So we'll go over to sets, list, and pick and choose here. All right, our pattern is going to be this that we just developed, and then our inputs are going to be these two. Let's go ahead and hide these, and what's revealed in the end is this pattern here. So this is just an example for using a simple, again, a simple kind of tiling arrangement that in this case is sort of overlapping all the possibilities, and then using the random pattern creation here to just kind of basically pick which ones that we're going to see within each cell at any given space. So within this square, it's going to pick, I guess, let's see, the first group, which looks like it's going to be 1. So that will be this one, and so on down the line. It's really amazing because actually what we get is a very intricate patterning here of continuous lines that completely transcend the grid from which it came. Right? These are all continuous polylines. If you join them, they'll be continuous all the way through. Okay, so this is one way to kind of introduce randomness to it. Of course, this is just one tiling system. These curves is just one way to think about it. There are many, many, many others. You can draw basically whatever you'd like, so long as things line up at the midpoint, or at least at a common area or a common point along these edges. Think about think about how it's going to have to connect to the next cell in space, right? So if you have one that is down here, for example, if I make a change to this, so if I just grab that point and move it, it should update, and actually it will fail. And you can kind of see what happened. Right, now if I move this back to the midpoint, it'll fix. Okay, so that's one thing to keep in mind as you're working with these tiling exercises, especially if you want them to connect from edge to edge. Right, you'll have to really design them and draw them properly so that that's possible. Another way to do the same pattern here is to kind of use a hexagonal grid. There's just one extra step that's included that we have to go through. And for that, I'm actually going to start again down below. So, because this one gets, I think it'll be easier. So I'm just going to turn that stuff off, and I'm going to start again because we're going to start with a different grid this time. Actually, we're going to start with, so let's go over to a vector here, and we're going to start with this hexagonal grid instead. Alrighty. And you can go ahead and change your sizing on this. Let's just experiment a little bit to try to fill up my screen. Pretty nice. Let's do that, and then let's see if these values still apply nicely. Well, maybe it's a little big, but it'll work. But anyway, I'll just drop that down to something like that. So there's mine. Actually, I might make these a little smaller to make it a little more dense. Okay, good enough. Now, with a hexagon, we have more than 2 options to exhaust all possibilities. We actually have 3, at least for the pattern that I'm going to show here. So I'm going to go ahead and draw a hexagon in Rhino. Right, so go ahead and draw a polygon. Oh, sorry. Type in polygon. Number of sides will be 6. You can set that up in the top of the command line. And I'm going to draw this at least so that they all are the same. So I'm going to put the kind of flat edge down, like that. Actually, I sort of wanted to make that a little bigger, but that's all right. And I'm going to make 3 of these. Okay. So I'm going to use the gumball, copy over with Alt, and make 3. Okay. So the first line is going to be this. That's our first possibility. The second one is going in that direction, and the third will be going in this direction. Those are the 3 possible crossing lines if we don't use the corner points, for example. Now the arcs that we have available to us is also going to be, so if we start with these corners and we swing like that, we can get 2 drawn from mid to mid there. We can also get 2 drawn from mid to mid here, right, to kind of match the scheme that we have on the left. And then of course we'll follow suit here so that it's basically the same tile exactly, just rotated. Right? Okay. So in this case we have to do something a little bit tricky. We actually have to put a bounding box around the whole thing, and then we'll remove the hexagon later. Because we're still, remember, we're still kind of dealing with this hexagonal grid is a little bit trickier to deal with. We still have to we have to use a rectangle mapping in order to do this. There's no hexagonal mapping component. So we have to kind of like basically fool it a little bit and then do a little work in the end. So let's go ahead and do that first. So the first thing is just going to be to bring in, it's kind of simple. We'll use a curve component here, and I'm just going to set multiple, and I'm going to select all this. So the all thing together, right? So this includes the hex boundary, and I'm going to do that for each one, okay? Select all of them. Make sure you select multiple there. And there we go, and then we'll do it one more time. All right. We have 1, 2, and 3. Now we're going to group all that. Okay, so go ahead and just type in your group here. Cool. And what we're going to do then is put a bounding box around these things. All right, so I'm going to go, I think it's in transform. Where is that? Can't remember. Let's find out. So I'm going to just type in bounding in here, and I'll grab the bounding box component, and you can find it in surface and primitive. That makes sense. And now it says here per object. What I actually want to do is make that union. I don't want 3 separate bounding boxes or whatever per line. Really what I want is just one to cover all of it. All right, so make sure that's set before you continue. And we're going to do that for the entire group. So you can see that there's a single box being drawn, a flat box around each one of those groupings of little tiles that we're going to use here. And you can turn those off. We really don't want to, you don't need to see that. And the nice thing is too is that this outline, we can get 2 different outputs here. One is, well, I guess they're both boxes. Let me see if there's a difference. I don't know that there will be. I'm going to end up using the second one in any case. So let's just move forward. No need to overthink. Let's go back then to our rectangular mapping. We know we want to go back to transform, affine, and rectangle mapping. The source is going to be that box for each one. We're going to need 3. Right, that's going to be the source. The target now is going to be another bounding box around all of the cells, the hexagonal cells. Remember that we need to flatten this. Okay, so flatten that output and put another bounding box around all of those. And you kind of see probably where this is going now. But in this case, now this gets a little tricky, and I apologize if this gets confusing, but in this case, we want these to be per object. So we want to turn off, there we go, that makes more sense. We're putting a single box around each one of those hexagons in the big grid, right? Now we can compare these with those, basically, right? We can move stuff that's in this box up here. And then the only question remains is to just get rid of the hexagon. We'll have to just kind of pull that out after the result is complete. Let's check that out in a moment. Okay. Now in this case too, I'm going to introduce a different way of developing random values. And I think it works a little bit better for this exercise. So I'm going to move that down a touch. And now we have a number of tiles, right? So I'm going to put 3 in there. That's the number of tiles we have. I'm going to go over to set, sequence, and I'm going to introduce the series component. This is really nice. Use it pretty often. Basically, this gives you a list of numbers that has a starting number, and you can put anything in between in terms of step size. We're going to leave that at 0 and 1. And then the number of things that we want basically is 3, so that's just 1, 2, 0, 1, 2. Now, if you have more tiles, you can change this. Just to kind of illustrate that, I'm just going to put that in through an integer. And then I'm going to repeat this data a certain number of times. And that number of times, again, is going to come from the number of cell outlines I have, right? The number of grids, hexagons. So we'll go ahead to set list length. That's how many things we have, 256. And then we can go back to set sequence and repeat data. So this is the data we're repeating, and we're repeating it so that we can exhaust 256 of these items in a sequence. Now what I want to do here is, it gets kind of fun. Instead of like, you know, what we did up here, which is to randomize the 0 and 1s, what I can do is just basically shuffle the organization of this repeating data set using the jitter component. So we go over to sequence here, again under sets, and we find the jitter component, which is also fun to use. So we can take this data, we can jitter it anywhere between 0 and 1. So let's just grab a parameter here, a baseline parameter. 1 is going to be most jumbled, and 0 is going to be less. So actually I'm going to start with 0 just to show it off. And then the seed, again, we can kind of make different iterations, and I forgot to show that on the last one, so we'll do it in this one. Now the last thing is to distribute the tiles. Okay, so we're going to go back to sets here, and we're going to reuse that pick and choose component like we did before, except this time I'm going to zoom in a little further, and I'm going to see these little plus signs pop up, and I'm going to hit that so that I have at least one extra, because I have three groupings I need to deal with. The distribution is going to be, the distribution pattern, I should say, is going to be this here from the jitter. And then it's just as simple as finishing all this off here. So we have geometry that's got to come out of our group. Right, so that's our geometry. I'm trying to do this in a way that makes, there we go. And our target is going to be these boxes, so let's do that. Now I'm going to go ahead and just move ahead here and just kind of put all those in. I'm going to put these in there, and I'm going to move that down and put that in there. Right, you can start to see there's a bunch of overlapping stuff going on. It's actually quite beautiful, in fact. The relationship between triangles, circles, and hexagons is made pretty clear here, which is nice. But it's not really what we're going after in this particular example. So we're going to keep moving. And then we just want to put the results of these remappings into this pick and choose component and redistribute based on the pattern above, the jittered pattern above. And then let's turn off that original hexagonal grid there. And before we, and then we could, well, yeah, go ahead and play with the slider here. And you're going to start to see more randomization if we go all the way up to 1, and a little less if we go to 0. In fact, that's kind of hard to see, so let's go on to the next steps here and just wrap this thing up. We have to then ungroup, so let's ungroup the results. So go ahead and type that in. And we're going to get rid of the hexagon that came with the group over here. And we used it in order to form a bounding box that we know would line up to the other bounding boxes. Right? That's what we used it for. I'm going to go to curve, and then I'm going to measure the lengths of each one of these things. I know that the hexagon should be the longest. Okay, so then this is a nice way to introduce sorting and kind of selections based on data. So I'm going to go to set, list, and sort. Okay, so by default this is going to sort things from small to large. I'm going to sort my k values, which would be my number values. I'm going to then reverse this list because I know that the last one is going to be the longest, because that's how the component works. And I want to actually just make it easier to find that, so I'm just going to reverse it so that I can just simply use a single list item component, and the first output of that, because this is an index of 0, is going to end up being my longest line. Any questions about that, feel free to just jump on the Zoom call and ask. Now the last thing is this, we need to kind of test for, we need to develop a calling pattern. We need to find a way to remove items from here based on this information. All right, so I'm going to go to math, and under operators I should find similarity here. All right. And the lengths that I'm going to test is going to be all of those, and I'm going to look for this one. So which one is going to be most similar to that one? That's going to give me a bunch of true false values. Okay, and true should always be the first one, so there's, to be honest, there's probably an easier way to do this. But anyway, that gives me the pattern that I need in order to basically remove the longest one from the list here. So I'm going to go to set, sequence, Again, call pattern, this one we used before. This is going to be the list of objects, the ungrouped, redistributed things. And then here's my calling pattern for that. Now I should be able to turn that off, and it looks like I removed the small ones. So actually what we want to do is, I guess, reverse this pattern back again and invert that by right-clicking. And what's revealed is the pattern left behind. So basically I removed the hexagon and I left only the tile geometry behind. And I get nice clean connections. Now you can see there's a repeating little figure in there, right? That's because the jitter is still at 0. So if I crank that up a bit, now we end up with a pretty nice randomized distribution of those tiles to form things like this, these kind of little sovereign objects, versus long lines that are continuous all the way throughout in a really complex way, maze-like, and so on. So that's one way of kind of working with hexagonal, I guess, hexagonal grids and tile shapes, which adds another edge basically, or adds multiple. Actually, like I said, adds 2 more edges than the box was able to give us. And because of that, we have more directions that these lines can go in, and more complex patterns that can be revealed. Give it a shot. Maybe you can try different. While we're in here, you can try a different tile. In any case, either of these is relatively easy to experiment with. Really, it's just a matter of drawing, some logical set of tiles that relate to one another in Rhino, and then kind of redistributing those using Grasshopper a little bit, and just a basic understanding of lists in order to do it.